So I'm still outside, still very sunny, still a bit warm, can't see. But we are in Unit 2, and we're starting Lesson 5. So we're talking points, segments, and zigzags. We're going to laugh about this video at a later date. I know we are. So let's start out with 5.1. What's the point? If A is a point on the plane and B is a point on the plane, then A is congruent to B. Okay. Try to prove this claim by explaining why you can be certain the claim must be true. Or try to disprove this claim by explaining why the claim cannot be true. If you can find a counterexample in which the if part, the hypothesis, is true, but the then part, the conclusion, is false, then you have disproved the claim. Alright, so I'm reading from the book here. It's true because two figures are congruent if there is a rigid motion that takes the first figure exactly to the second. So what I'm going to do here is draw a plane. It's very difficult to draw a plane. A plane on paper looks like that. And how we can picture this in real life is if you just look at the floor. The floor is an example of a plane, okay? Or the ceiling, or a wall, or, I don't know, a table. Okay, those are all considered planes. Now, if I have a point on the plane, and I have another point on the plane, I can actually move point A to point B by directed line segment. And it becomes A prime, except I'm going to use the same colors. Okay, so it is true. All right, what else can I tell you? Yep, a translation using directed line segment AB would take A to B. A reflection, oh, let's do that. If I connected AB and I did, let's just draw some construction lines. A circle center A with radius AB, a circle center B with radius AB, that's amazing. Mark the intersections. I just made a perpendicular bisector of AB. A perpendicular bisector of segment AB. And then we can do a reflection across line M. Let me name that line M. And then A goes to B. Okay, so we could do a reflection also. Or, I probably shouldn't delete everything, but you can always rewind if you want to see what I wrote. Ooh, if I write in cursive, it's easier to erase. Or, I could do, let's do green again. Just make it a little thicker. If I find the midpoint, which I just did with a perpendicular bisector, we found the midpoint. I don't need the perpendicular bisector anymore, but I need the midpoint, which you can find by the perpendicular bisector. I can do a rotation. So 3 different transformations. Take A onto B. Therefore, yes, A is congruent to B because of rigid motion, okay? All right, so what's the segment? Prove the conjecture. If AB is a segment in the plane and CD is a segment in the plane with the same length as AB, then AB is congruent to CD. Okay, we're going to get into just a little bit of proofs. Proofs are very important in geometry, and we take a decently relaxed look at proofs. I tend to write what I call column proofs, not paragraph proofs. And I think it's probably just because of how my mind works. So we're going to say AB is a segment in the plane. and CD is the segment in the plane with the same length as AB, then AB is congruent to CD. All right, so how are we going to do this? Sometimes it can be easier to do counterexamples. That means proving it's not true in one way, but we're going to try to prove that it's true. So we know that two figures are congruent if there is a rigid motion that takes the first figure exactly to the second. Okay, so that's what we know. So I'm going to just bullet point it. Translate segment AB, that's how I write segment AB, by directed, set up my cool pen to do undos. Let's see if it works. Yep. By directed line segment AC. Okay, remember early on we called those vectors? So what I'm really doing here is taking A to C. Then I'm going to rotate it. So that becomes, let's just make our new one A prime, B prime. Cool? All right. Now, A prime coincides with C. Can you see that prime there? Now we're going to rotate it. A prime, B prime, segment A prime, B prime. We're going to say by an angle. B prime CD, let me show you that. We have to drag this back down. I assume you're drawing along. So we're going to rotate that by B prime CD, so this angle right here, and that's going to be clockwise. Find my pen. There we go. So that, I think it's A prime coincides with D, if I remember correctly. Yep, but actually what we're going to say here, I should be more accurate, the book is telling me to, so that once we rotate it, we have to double prime it. A prime, double prime, B double prime coincides with CD. So if I drag back up, let's look at it. So I'm going to go back to green. So we just rotated it. So now we're going to be right here, and it's going to be A double prime, B double prime, right on top of CD. That's how we know that they are congruent. And there we go. So there are rigid motions. There are a sequence of rigid motions that take segment AB onto segment CD. Therefore, they're congruent. Okay? All right. So let's try this next one. Zig, then zag. Sounds like we're doing a little basketball move. So here we have these are all called our givens. If I look at these up here, these are called my givens. Okay, so in geometry, when we have a problem statement, the problem is going to give you information, and you have to do something with that information. Okay, it's really hot out here. So those are our givens. It's given that we know segment QR is congruent to segment XY. QR congruent to XY, and we've marked them with single ticks. RS is congruent to YZ. RS, YZ, and they're marked with double ticks. And then angle R is congruent to angle Y. It's marked with one arc with a tick in it. Okay, so here are some statements about two zigzags. Put them in order to write a proof about figures QRS and XWZ. All right, therefore, figure QRS is congruent to figure XYZ. I think this one is going to be last. So we're going to number this number 5. I can only say that because the therefore, and it's like a final statement. Therefore, a figure is congruent to a figure. Seems like the last statement. Okay? So I definitely like that one. Maybe not. They say that is number. Yep, we're good. It's right. I just got confused at the answer key. So let's read number 2. S prime must be on ray YZ since both S prime and Z are on the same side of XY and make the same angle with it at Y. No idea what that one's talking about. I just need to move that yellow dot. Segments QR and XY are the same length, so they are congruent. Therefore, there is a rigid motion that takes QR to XY. Apply that rigid motion to figure QRS. QR and XY are the same length, so they are congruent. Therefore, there's a rigid motion that takes QR to XY. That one might be number 1. Since points S prime and Z are the same distance along the ray from Y, they have to be in the same place. That one might be number 2. If necessary, reflect the image of figure QRS along XY to be sure the image of S, which we will call S prime, is on the same side of XY as Z. That actually could be number 2. One of those two. And then number 2 again, S prime must be on ray YZ since both S prime and Z are on the same side of XY and make the same angle with it at Y. All right, so I'm getting a little lost. I'm going to go ahead and do number 3. It says segments QR and XY are the same length, so they are congruent. Therefore, there is a rigid motion that takes QR to XY. Apply that rigid motion to figure QRS. So we are going to translate and then rotate. And we would get QR, I'm writing it right next to it so I can see it. Q prime, R prime, S prime. Okay? So this one is definitely number 1. And I'm still saying this one is definitely number 5, just because of the therefore. So let's find number 2. Let's read these again. Since points S prime and Z are the same distance along the same ray from Y, they have to be in the same place. I like that one. If necessary, reflect the image of figure QRS across XY to be sure the image of S, which will call S prime. Okay, so that one is number 2. We did a translation and then a rotation. They did a translation and then a reflection, which is fine. So that one is definitely number 2. And I think this one is definitely number 3. Nope. Let's read this one. S prime must be on ray YZ. Yep, since both S prime and Z are on the same side of XY and make the same angle with it at Y. All right. So there we have number 3, and number 4. Okay, these are hard because they're using words that I wouldn't use when I do proofs, but you have to think through the logical steps of it. Okay, step 1, 2, 3, 4. I know the beginning and the end. The middle can be a little, you can argue that your way is better than my way, and you could be right. Okay, we're going to get from the beginning to the end in different ways. So when I grade students' proofs, I actually have to read through each step to try to think through their logic. I sort of put myself in the shoes of the student so that I can read through the logic. It can be sort of hard. So reading through the book's logic can be hard too. All right, so take turns with your partner stating steps in the proof that figure ABC is congruent to figure EFG. Okay, we're just going to write a few of them. So I can say that AB is congruent to EF. And I'm going to translate one figure to another by directed line segment AE. Okay, that means that my new figure is going to look a little bit like this. A prime, B prime, C prime, D prime. Okay, now I'm still going to rotate because that's what I do. If I can see the rotation, I'm going to rotate the figure counterclockwise until, it doesn't matter what points you pick, until B prime coincides with F prime. That's a funny looking F, isn't it? F prime. And then I can say that all the parts of the figure coincide. Therefore, the figures are congruent. Okay? I know my proof is pretty lame compared to theirs in the last page, but proving that figures like this are congruent, you're just trying to prove that each piece and part are congruent. And actually, up here, we should actually state all the givens, just like they did in this one right here. Okay, they stated all the givens. We should have done that in our proof also. Okay, that would have made it mean a lot more. The sun went behind a cloud. All right, and our summary. Go ahead and read through it. You got a copy of the summary, so it's fantastic. But again, proofs are important. Proofs are just a way to logically think. I think of proofs as a way to show someone else how you think. Okay, so that would work too. And we'll get into more proofs as time goes on. All right, good work today.